Hello, and welcome to this Aldic Riviera-PRO video. My name is Chantel, and I will be going over some of the more advanced features of the Waveform Viewer. This viewer, in and of itself, is already a powerful debugging and simulation tool, and you can take its usefulness even further with some of its features I'll be talking about in this video. So, let's get started. I have this Riviera-PRO example design called DataPath opened. This can be accessed by going to the Riviera-PRO examples folder, then expanding the VHDL folder, and then there's DataPath. I'll be running the sample designs project runme macro with the run command commented out. Now I'll execute macro. Once the macro is done running, a Waveform Viewer window opens with the top test bench signals added. I'll switch over to the debug perspective. And now I'll demonstrate one of the advanced features of the Waveform Viewer called Splitter. To use it, just right-click inside of the Waveform Viewer space and click on the Splitter option. This opens up another waveform view, and I can add other signals to it outside of the top test bench. For example, I'm going to drag the U0 signals into the new Splitter view from the hierarchy window. I can even adjust the Splitter view, or add another view if I'd like. To remove a splitter view, just right-click and select Close Splitter option. This is all pretty handy because you can have a distinct separation of signals from different hierarchies of the design. And you can have a better time monitoring the values, comparing them, and seeing how these different signals affect each other. So now I'll run the simulation, and notice that these two separate views are horizontally synced with the simulation time. So it doesn't matter where your cursor is within either of the waveform panes. I'm going to reset simulation, and notice that the signals stay within their splitter view. Thanks to the splitter, I now have a more comprehensive view of the simulation results. And with all of these signals added into these waveform views, they can also be used to generate signal breakpoints. By right-clicking on any of the signals within the Waveform Viewer and clicking on Set Signal Breakpoint, I can choose it to be a transaction, event, or value type. The two important ones here are event and value. So I'll first set an event signal breakpoint using the loadout signal. This sets a signal breakpoint where it will stop the simulation whenever any change in the signal occurs. So now when I click on Run, the simulation stops at this part of counter VHD, and this is because loadout changes from uninitialized to 0. When I click Run again, the simulation stops at this part of Control FSM, and loadout has now changed from 0 to 1. With this breakpoint and the splitter view, I can see how Qout of the top test bench changes while loadout transitions from high to low. I'm going to reset the simulation again, and this time I'll add a value breakpoint using Qout. This breakpoint will stop the simulation whenever the specified value occurs on the signal. For this breakpoint, I'm going to set the value of 00BB in binary. And as a side note, in this debug perspective, there is a window where you can manage all different types of breakpoints. Clicking on this Signal Breakpoints tab lists all the breakpoints I've set so far. And it also lists their condition, the value, and the hit count. If the window isn't opened, head to this section here and select the Signal Breakpoints icon to open it. I'll disable the loadout event breakpoint, and now I'll run the sim. Notice how the simulation stops here because Qout changed from all zeros to 00BB. Now I'm just going to end the simulation, delete my breakpoints, and I'm going to do a new initialization and select Options, then Dataset. I'm going to enable Show Event Source, click Apply, then OK, and then OK again. Back in my waveform view, I'll add the same signals from before. Now I'll talk about cross-probing. The Waveform Viewer allows for cross-probing with other windows of Riviera-PRO. For this context with Show Event Source enabled, I can cross-probe with the waveform results to show me where the cause of the signal's event occurred within the HDL code. Also, double-clicking on a signal in the waveform window brings me over to that signal's instantiation within the HDL code. And vice versa, I can add a signal from the HDL editor to the waveform. Back in the waveform window, I can click and drag the signals into the Signal Breakpoints window, Console window, Drivers and Readers window, and even the Watch window. So this time, I'll run all of the simulation. I'm going to use Loadout again for this example and drag it over to the Drivers and Readers window. Notice that when I click on the reader's name, it shows how the value of loadout, which is load in this part of the code, is the condition for dout getting the value of din. And when I go back to the waveform window and move the cursor to the first event occurrence of one of the bits of qout, I can right-click and show event source. And notice that this matches where the reader is getting its value, which further confirms that qout is the value of dout that gets assigned the value of din whenever load is 1 or high. As demonstrated, cross-probing, signal breakpoints, and the splitter are all useful Waveform Viewer features, and using all of these tools together creates a comprehensive debugging and simulation system that can improve the overall debugging process. That's all for this video. Thanks for watching.